This video shows the main hardware component parts inside your computer, how they work together, and why understanding them matters for exams and buying devices. Please press the subscribe button if you would like more of these videos explaining theory concepts. I really value your support and input. Remember to set up your Cornell page, cues on the left, notes on the right, and summary at the bottom. We use computers daily. We click, we type, we tap. But most learners don't know what happens inside. In CAT, knowing inside hardware helps you to read specs, choose devices, and explain slow computers. On this video, we focus on the CPU, the RAM, storage, GPU, plus our input devices and our output devices. In a person, we have similar parts that help to keep our body functioning. The brain of the body is similar to the CPU because it thinks and decides what has to be done. Our short-term memory, that which is on our table right now, is similar to the RAM because it is only retained for a short while. The knowledge we have and can recall, or our long-term memory, does the same as a storage device in a computer. Information is retrieved often to work with. Our senses, which retrieves information around us like our eyes, ears, and skin, is our input devices. And lastly, how we communicate, our facial expressions and voice, is our output devices. The CPU is the main brain, and CPU stands for Central Processing Unit. It follows instructions, makes decisions, and tells other parts what to do and when to do it. When you open an app, calculate in Excel, or play a game, the CPU is doing the thinking incredibly fast. In the specs, we see the clock speed in gigahertz, and the higher number of cores, the faster the execution time. Both of these values, the speed and the number of cores, means increased execution times. Cache memory helps in faster retrieval for next functions, and examples of the brand and models are the Intel, such as i3, and now the newest version is i9, as well as AMD Ryzen. Here's an example of a spec that you might find in an exam paper. Intel i5 3.5 GHz 4 cores. Cache is very small but super fast memory inside or very close to the CPU. It stores data and instruction the CPU uses repeatedly, so it doesn't have to go back to the RAM every time. Think of it like keeping your most used textbook on your desk instead of a shelf far away. In exams, cache is described as high-speed memory that reduces access time for frequent use data. RAM is the computer's short-term memory or working memory, and RAM stands for Random Access Memory. Your open tabs, documents, and browsers live here, holding the programs and data you are currently using. RAM is also volatile memory, which means when the power is off, everything is lost. That's why you save to storage. Just like working memory, if you try to juggle too many thoughts at once, you slow down. Same with computers. If the RAM is too small, everything feels slow, even with a fast CPU. In specs, you can see the capacity or the size in gigabytes, and it's usually in multiples of 2. Then DDR3, DDR4, DDR5 is examples of the speed of the RAM. Upgrading your RAM is also the fastest and easiest way to upgrade an old PC. And if the RAM gets too full, the operating system can use a part of the storage as virtual memory. It pretends storage is extra RAM, but it is much slower. Storage is the computer's long-term memory. Files, photos, videos, and applications stay here even when the power is off. When you open a file, the computer fetches it from the storage into RAM so the CPU can use it. When you save, it goes back to storage. We have two main types of storage devices. The first is the older HDD or hard disk drive, and the newer SSD or solid state drive. The HDD, as you can see in the picture, has a spinning magnetic disk, while the SSD has no moving parts. The HDD is also cheaper per gigabyte compared to the SSD, which is more expensive per gigabyte. HDD also has larger storage capacity than SSD, which has a limited storage capacity. The HDD, which is sensitive to bumps, is not ideal for portable devices, while the SSD is. And then lastly, you use HDD for long-term storage or archiving, and SSD unfortunately has a limited write or read cycle. The same memory is used in memory sticks, which explains why they break that easily. A person needs senses, our eyes, our ears, and touch to get information, and ways to communicate, which is to speak, to write, or to move. Computers are the same. Input devices is our senses, and examples includes the keyboard, mouse, mic, and camera. Output devices is how computers communicate back. They include the screen, printer, speaker, and projectors. When you type or click, you're feeding input to the CPU. When the screen displays, that's output. Now we will look at the motherboard and power. The motherboard is similar to our nervous system, and the power is the same as the energy that we get from food. The motherboard is the main circuit board that connects the CPU, RAM, storage, and other ports. Data travels along these buses, tiny pathways, so parts can send and receive signals at high speed. Just like your nervous system connects your brain to the body, the motherboard connects computer parts. And energy? Even the smartest brain cannot work without power. Computers need stable electric power. Unstable powers like surges and cuts and load shedding causes crashes and damage, like a person fainting. The GPU, or the picture brain. Modern computers often have a GPU, or a graphics processing unit. Think of it as a specialized picture brain. It's very good at drawing, updating images, videos, and 3D scenes extremely fast. That's why gamers, video editing, animation, and 3D modeling needs a powerful GPU. And don't forget about the engineers. If you just browse and write documents, a built-in GPU is fine. If you game or do 3D work or graphic designing, you need a strong, dedicated GPU. Now you may ask, why does this matter? When you understand the parts, you can also read a spec sheet and know what the numbers mean. You can also choose why one computer is better for gaming and another is fine for schoolwork. And you can also fix, helping you to diagnose problems like a slow PC and to decide, do I need more RAM or faster SSD? And this is also called troubleshooting. Or should you just close some apps and this is exactly what is asked in the NSC papers. Pause the video and answer these short questions in full sentences. I will first read and then give the prompt before pausing again. You will see very similar questions in CAT tests and exams. The first question: define CPU and what does gigahertz mean? RAM and storage are not the same thing. Explain the difference. A gamer wants a bigger gaming PC. Should they upgrade the CPU, RAM, or GPU? Explain why. Name one input and one output device. What is cache memory and why does it improve overall performance? Please pause the video now and then we'll get back to the answers. The CPU is the central processing unit or the main brain, and GHz stands for gigahertz, and that's how many operations per second can be done. The higher this is, the faster the CPU. RAM is the working memory, which is volatile and holds current apps. Storage is permanent, non-volatile memory and keeps the data even when the power is off. If you want to improve your gaming PC, definitely go for a GPU. CPU and RAM matter, but GPU matters most. One input device is a keyboard, and one output device, for example, is a screen. Cache memory is high-speed memory used to hold recent or frequently accessed data in order to be able to retrieve the data faster. Completing your summary box. This is important and is best done from memory without looking at your notes. In your summary box, write 5 concise points that capture the core ideas. The 5 core ideas could be: what is the CPU and what does GHz mean? The RAM versus storage, what is the differences? HDD and SSD advantages and disadvantages. One input device, one output device, and why GPU matters for gamers. The summary is your revision checklist before tests. Keep it to 1 or to 2 sentences per point. Thank you for watching, and please subscribe for our next video, RAM versus storage and information overload. This video will help you to understand all memory concepts clearly. Subscribing would also remind you when a new video has been released, and any likes, comments, and sharing would really be appreciated and helps me to create even more intentional videos. Thank you once again.